Okay, so what if I told you that the key to solving our energy crisis is hiding in plain sight, in a cosmic puzzle 93 million miles away? We're about to connect a mystery about our sun that stumped scientists for decades with one of the most insane, most ambitious engineering projects humanity has ever attempted.
You know, we look at the sun all the time. It seems pretty straightforward, right? Just a giant ball of fire. But if you look closer at its atmosphere, this wispy, ethereal thing called the corona, it's hiding a secret, a paradox, really, that seems to completely break the laws of physics as we know them.
And this isn't just some abstract science problem. No way. Cracking this solar secret could be the absolute key to achieving one of humanity's wildest dreams, building our very own star, right here on Earth. Imagine a tiny sun that could power our entire world pretty much forever.
All right, so first things first, let's dig into the mystery itself. This is a puzzle that honestly feels like it rewrites the rules of physics.
So here's the deal. The surface of the sun, it's hot, a few thousand degrees. But here's the crazy part. As you move away from the surface into its atmosphere, the corona, the temperature just skyrockets to over 1,000,000 degrees. That makes no sense, right? It's like walking away from a campfire and suddenly getting way, way hotter. How is that even possible?
Well, the answer is in what the sun is actually made of. It's not a solid or a liquid or even a gas. It's plasma, the fourth state of matter. You can think of it as this superheated, electrically charged soup of particles. And somewhere in that cosmic soup is the solution to our million-degree mystery.
So, if heat isn't just, radiating outwards like you'd expect, something else must be happening. Something has to be carrying all that energy up into the corona. But what could it be? Well, scientists have a pretty good idea. It's invisible waves, rippling right through that plasma soup.
And here's our prime suspect, something called the Alfvén wave. This isn't your typical wave. It's a magnetic wave that travels through plasma. A great way to picture it is to think of the sun's magnetic field lines as guitar strings. The plasma particles literally vibrate along these strings, and in doing so, they carry a ton of energy across huge distances. Now, this idea has actually been around for a while. Way back in 1942, a guy named Hannes Alfvén, who later won a Nobel Prize for this stuff, he figured that the sun's crazy environment was the perfect place for these powerful waves to form. So just imagine the sun's boiling, turbulent surface constantly plucking its own magnetic field lines. Those vibrations, the Alfvén waves, they're just like ripples traveling down a giant cosmic guitar string. And they carry more than enough energy to superheat the corona to those insane million-degree temperatures.
Okay, so we've got a theory for how our star pumps out all this energy. The big question is, how do we bring that power down to Earth? Well, the plan is to build our own star, a miniature sun, bottled up and controlled by what might just be the most ambitious project we've ever undertaken.
And you'll never guess where this idea came from. It wasn't dreamed up in some lab. It actually started at a Cold War summit. Yeah, seriously. Back in 1985, Ronald Reagan and Mikhail Gorbachev got together and agreed to work on fusion energy for peace, a peace initiative that kicked off this incredible, multi-generational scientific mission.
And from that one handshake, the whole thing just blew up into this massive global collaboration. We're talking 35 nations all working together, pooling all their money and their best scientists to build something the world has literally never seen before.
And this is what they're building. It's called ITER. It's basically a gigantic magnetic bottle, a tokamak, and its job? To hold a plasma that's even hotter than the core of the sun, and use that heat to smash atoms together, to fuse them, and release just a colossal amount of energy.
The name, ITER, started out as an acronym, but in a cool little twist, ITER in Latin also means the way, or the journey. Kind of perfect, right? For a project that we're all hoping will show us the way to a whole new future for energy.
So what's the end goal of this journey? What's the one big thing that will tell us if this whole massive project is a success or a failure?
Okay, to get this thing running, ITER is going to need a huge amount of juice. The systems that heat up the plasma and power those giant magnets, they'll suck down about 50 megawatts of electricity. But, and this is the important part, in return, the fusion reactions inside are designed to pump out 500 megawatts of power, a massive difference.
So you see the math here, right? We're talking 10 times more energy out than we put in. That is the entire point of ITER. Its job isn't to power our homes directly. Not yet.
Its mission is to hit that 10x gain and prove once and for all that fusion power isn't just a fantasy, that we can actually get more energy out than we put in. But look, when you're aiming for something this big, it's never going to be easy. There are huge challenges, a lot of controversy, and a ton of risk. This is a massive, high-stakes gamble for the future of our planet's energy.
And there are definitely skeptics, a lot of them. The World Nuclear Association, for example, points out that the technical challenges are just staggering. I mean, think about it. You have to contain a plasma that's 100 million degrees hot. You have to build materials that won't get shredded by all the radiation. And those are just a couple of the problems.
Yeah, this whole thing has been a long time coming. The idea started way back in '85, but they didn't even start building the thing until 2013. And the project has had some pretty major delays. The first big experiments are still years down the road.
And this really gets to the heart of the debate. On one side, you've got the critics. They point to the insane cost overruns, we're talking over 20 billion euros now, and all the delays. And they make a really good point. Couldn't that money be used on renewables that we know work right now? But on the other side, the supporters are looking at the ultimate prize, potentially limitless clean energy. The fuel comes from seawater. There are no carbon emissions, no long-term radioactive waste, and it's physically impossible for it to have a meltdown.
So that's the big question, isn't it? What is ITER, really? Is it humanity's greatest hope? A star in a bottle that could literally save our planet? Or is it a fantastically expensive mistake? A beautiful dream that's just too costly? You know, for better or worse, the answer's being built as we speak, piece by massive piece, down in the south of France. I'm curious, what do you think?